video is used to show how to make a chart and put it into your lab report. For this video I'm using Microsoft Excel, but you could just as easily use another program such as OpenOffice or Google Docs. Some of you don't really realize how to actually use Google Docs, so I'll show you real quick. You get on the internet and just go to Google. You type in Google Drive. If you're logged into your Google account, click on that. You can actually open a new document by going to Create, and then you can create a text document, so that would pretty much be like Microsoft Word. There's presentation, so Microsoft PowerPoint. Spreadsheet would be the equivalent of Excel. So there's all of those. So if I want to make a spreadsheet, I click on Spreadsheet, and it is very much similar to Microsoft Excel, and this can be used to make tables as well. So, but I'm going to go back to Microsoft Excel because I prefer to show you in that program. So as you can see, I have two panes open. I have my blank spreadsheet, and I have the lab procedure, which shows how the tables should generally look. So you probably have these already set up in your notebook, and now we want to make them electronic so we can put them in our lab report. So I'm first going to just construct these tables very simply. So I want to have a column for trials, I want a column for volume, I want a column for mass, and a column for density. And then we have three different tables, one for the beaker, one for the graduated cylinder, one for the pipette. So we can make one and then copy and paste it 2 more times. But I want to put a title on top of the table, so I'll select all the cells above it, and I'll go to Merge and Center. That's this tool right here, and I'll just type just generally beaker, signifying that this table is for the beaker data. Okay, so I have 3 trials, 1, 2, and 3, and then density is going to be our calculated column, and that's going to be calculated by taking the mass divided by the volume, because that's the definition of density. So I could actually put in another column up here, and I could show that I'm going to be taking, I could just label these columns A, B, and well, I don't need a label for that one, but I'm going to show that I'm going to calculate the density, so I'll put D is equal to, I want the mass divided by the volume, so B divided by A. So that's just showing me how I'm calculating that. Or I could just even more simply just put B divided by A. You can make this look better, you can make these bold, you can center everything. We could also put lines, so I'll select all borders. Okay, so it looks a lot better. So there's one table, and then if you'll notice that I'm actually going to end up calculating the average calculated density. So I could put a row below for average, and then looking ahead, you'll see that we're actually going to end up calculating the standard deviation too. So I could put in another row for standard deviation. I could just abbreviate that as TD dev. Make those bold as well. We could also make those part of the table. So there you go. So we have a nice table for our beaker data. I could go ahead and copy and paste this table some more. So I think I can. Okay, so I'm going to select all. I'm doing a Control C command and Control V, and it copied and pasted that table. I want one more, so I'll stick another one right here. Okay, so there I have some tables. Obviously these are not all going to be tables for the beaker, so I'm going to want one for my graduated cylinder, and I'm going to want one for my volumetric pipette. There we are. So we have 3 tables, and we're ready to put in our data. So I already have data from another spreadsheet. I'm just going to copy and paste it in here. But you're going to actually take your data that you got in the lab and you're going to just copy in. Oh, you're not going to copy it. Well, yeah, you will. You'll input it into the Excel from your lab notebook. So I have some data here. Copy and paste that. Here's some grad cylinder data. Copy and paste that. And then I have some pipette data. Copy and paste that. Okay, so we're pretty much done stealing data from that spreadsheet. So I will close out of it. Okay. So now I would like to just double check that all of my significant figures for measurement of all these instruments are correct. So the beaker it's within 5%. So I'm not going to have any decimal readings on the beaker. The first graduation mark was 10 milliliters. Some of you might have used 5 milliliters. That's fine. So it'd be halfway to the 10. But I don't have any more precision beyond putting 10. So I'll leave that how it is. That's perfect. As you can see, this was the mass data that I had. And then what to do the graduated cylinder, I had volumes of 2.60, 5.10, and 7.30. When this pasted over, it's adding a significant figure. When I actually had those volume readings, I guess, well, more realistic data is going to have two decimal places because you have the two known digits and the last estimated one. So make sure you input all those digits. But for the sake of this lab, I mean, I must have used a different graduate cylinder. I must use a smaller one that had, a larger one that had less precision. But you guys are going to have two places after the decimal point. So I'll just make up some data since this data is it doesn't really apply to yours anyways. So you're going to be changing this. You're going to be putting your data in here, of course. So I'm just making up other data. Make sure you're not making up the data. I mean, input the data that you actually recorded in the lab. Okay, so my graduate cylinder, we had two places. So I knew it was between 7.3, 7.4, and I estimated that last digit of 7, and I did the same things for those. So that's what that would have been. And then if I go down here to my volumetric pipette, the volumetric pipette has a line that is exactly at 5 milliliters, and it's precise to two places after the decimal point. So those should all be the same. Okay. So now I want to calculate my density for all of these. I don't want to calculate it on a calculator and then type it in. I just want to do it in Excel. I want to calculate the actual values through Excel. So in order to do that, I'm going to select the cell. Just going to hit equals. And then I have B divided by A, or mass divided by density. Mass divided by volume, I'm sorry. So we take mass, you just click on it. Then I'm going to hit slash or divide by volume. Hit enter and it'll calculate my density. I have 3 sig figs here, and we'll call this 2. So 0.88. Those are that's a good amount of sig figs for this calculation. So instead of having to type it in multiple times, I could just click on the cell and it puts that little square, and I make sure my cursor goes to the black cross. I click and drag down, and what that does is you can see that it changes the cells as I drag down. Okay, these ones have too many digits, so I'll select them. I'll go up here to number, and I want to decrease my decimal point. So when I hit decrease, I lose a level. So that's exactly what I want. So I want to calculate these densities for the graduate cylinder and the volumetric pipette as well. So I could just copy and paste those. Copy, paste, and you'll see that it actually is taking this data now. I have 3 sig figs here, so these should be 3 as well. So I'll select all 3 of them, go to my number. I'm going to increase decimal, so that's obviously too much, so I'm going to decrease it until I have 3, and there we are, perfect. And then lastly, I want to go down to the volumetric pipette. Again, I'm going to want 3 sig figs because these are both 3, and there's my data for that. Okay, so now I have all of my data in there. I have a calculated density. I don't know why I hit save, but I have a calculated density, and now I want to calculate my average and my standard deviation. Okay, the average is just going to be the sum of these three divided by 3. So start parentheses, that cell plus this cell plus this one divided by 3. So that's my average. I want my average to be the same amount of sig figs as what I use to calculate it. So I will decrease the decimal, copy and paste that over here. Again, it's using this data now. I want to increase the decimal for this one since I was using a more precise instrument, and then copy and paste that down for the volumetric pipette as well. Okay, so now I have all my averages calculated. The next thing is I want to calculate my standard deviation. Standard deviation, I can you can see the equation used is right here if you've never used that before. Standard deviation is the square root of the sum. Here, I'll zoom in on this so it's easier to see. Okay, this sigma sign means the sum of everything that follows the sigma. So I want to take x minus x average, square it, and then add them all up. So x is the density for each individual trial. So these are the individual trials. X average is the average calculated density, so that's just average I just calculated. And then n is the number of trials, so I would have 3 trials here. So to calculate the standard deviation for the beaker, I'm going to set up a formula. I like to set it all up and then click on the cells, so I'm going to hit equals. I can see that this is ultimately a fraction. See that fraction there? So I'm going to put parentheses on top, parentheses on the bottom, and I eventually want to be taking the square root of everything. In Excel, to put a square root, you just type in SQRT left parenthesis. So that's just taking the square root of everything that's in the parentheses, and then I want to encompass that whole thing. So here I have a fraction with parentheses above and below, and I'm taking the square root of the whole thing. Now I want to set up the bottom because that's the simplest part. It's n minus 1. Well, n is the number of trials, so for all of these I have 3 trials, so I'm going to put in 3, and that's minus 1. Okay, so that part's done. So now I'm at the top. So this is that sigma notation. So I want to take the sum of x minus x average squared for every trial. So I have 3 trials, so I have 1, and then I'm taking the sum, so another one, and a third one. So the first one, well actually one more step is we have to take the square of them. So there's the first one, I want to square it, so caret, so we're saying I'm raising it to the second power. I want to square this one as well as this one. So here I have the first part, this is the first trial, so it's x minus x average, so here's x, so the density for that trial, minus the average density. Go down here, this trial, minus the average density. Go over here, this trial, minus the average density. Okay, so now I have a successfully calculated square root. Once I hit enter, that'll be my square root value. And there it is, there's my standard deviation. I used these values to calculate the standard deviation, so I have 2 sig figs, so this should also have 2 sig figs, so I will decrease my decimal to 2 sig figs. So I can easily copy and paste that standard deviation here and here, making sure the sig figs are right. This one has 3, so I'll increase the decimal. This one has 3, so I will also increase the decimal. So there, I have all of my tables. I can just decrease this column width so it looks better. I'm ready to take these tables and put them into my lab report. So I'm going to save my spreadsheet. I will just call it density lab tables. I'm just going to save it to my desktop so I can easily find it. And then I will open my lab report template. You may or may not have already started writing different components of this, that's fine. But I'm going to want to put it in my data and calculations section. So it's going to be right here. It doesn't have to be bolded, so I can delete that bullet. And this is where I want to insert that table. Actually, I wouldn't mind having it indented to the same level as bullets. So I'll insert the table here. In order to insert a table from a file, I'm going to go to the top and click on the Insert tab. In the Insert tab, I'll actually go full screen now since we're done with this one. In the Insert tab, where am I? Decrease the size of this. Insert tab. Okay, so I'm going to go to Object. So Insert Object. So I want an embedded object. In this case, I want an embedded Excel table. So Object. A box will pop open. I want to create from file. So click on the Create from File tab. And then I'm going to browse for that document. So click on Desktop, and I called it Density Lab Tables. There we are. Before I hit OK, I want to make sure that I do not have Link to File checked, nor Display as Icon checked. If I have Link to File checked, it's just going to show a hyperlink to that spreadsheet. And if I have Display as Icon checked, it will display as a Microsoft Excel icon. I don't want either of those, so I make sure they're unchecked, and then I'm going to hit OK. Upon hitting OK, it will insert those tables into my document, very simply. Now, looking at this, I immediately see that I forgot something, and that thing is the units. Okay, I secretly purposely forgot that just to show you that you can still edit tables or anything that you embedded into this document by double-clicking. Okay, so my volume should be in milliliters, so I want to specify that. So left parenthesis, milliliters, and parentheses. Okay, well now it's kind of hard to read. So if I want to adjust this column height and column width, I'm going to move it over this and get this icon and double click, and it will automatically adjust the size. Mass should be in grams. Good. And density should be in grams per milliliter. And I want to make that column bigger. So I can now just copy and paste these titles so that they are consistent in all the tables. Make them bigger, make them bigger. There we go. It's very important that when you are putting the units in a table, you're not putting them with the numbers, because if you put them with the numbers, for instance, if I put 8.8 grams, well, look, all my calculations are messed up then. Excel can only take raw numbers for calculations. So I just want to take 8.80. Also, you'll notice if I made a typo with my mass, so say instead my mass is actually 8.83, it'll automatically recalculate all of this stuff for me. And that's what's nice about actually inputting the formulas rather than calculating it in your calculator and then typing it into the table. That way you don't have to recalculate anything, you can just change the data. Also, I'd like to point out that if I did not have my borders shown, so if I didn't have any borders, click out of that, it's kind of hard to see these tables, and when I go to print this, I won't see these very light lines. So I want to make sure that I have all of those borders shown. Actually, that's too many. There we go. Oh, now I just undid everything. Okay. I will have to manually select all this stuff. No big deal. Okay, there we go. So, and then you'll notice when I click out of this, it no longer fits on the sheet. Well, that's very easy to fix. I could just click and drag it over a little bit. That's not working for me, I guess. So I could click before and hit back, and that'll move it over. Or I could squish it by grabbing those bars. I can make it bigger, smaller, whatever I need to do. I can do it that way. Okay. So that is how I would put tables from Excel into a Word document. And you could also do that with graphs. Okay, and that concludes this video.